All right, so for video 3 here, some properties of exponential functions. So we know an exponential function is f of x equals a to the x, where a is greater than 0 but not equal to 1. Well, we could tell when we graph them, I'm just going to sketch one here real quick. We could tell it didn't matter if we did the 3 to the x or if we'd have done the 1/2 to the x. Either way, when we graphed them, we could see our domain was negative infinity to infinity because it kept going to the left and to the right. Our range was 0 to infinity because remember, both of these had that horizontal asymptote. They're at 0, so our graph was above it. And then you can just kind of read through it. Remember, if a is greater than 1, there's a growth factor. If it's increasing function, so the graph rises to the right. You can, like I said, read through these a little bit here. If a was between 0 and 1, then it's a decay factor, which means it'll be decreasing as it goes from left to right. Also there on number 6, each exponential function is 1 to 1. That means, we're going to talk about that here in a few minutes, that if you have a to the m equals a to the n, as long as their bases are equal, we don't have to worry about their bases because that means their exponents have to be equal as well. So then we can find where m is equal to n. And also, because it's 1 to 1, remember that it means that f has an inverse. And do you remember what its inverse function is called? The inverse of an exponential? Well, it's a logarithm, and that's going to come up in 3.2. All right, so because we have that, number 7 talks about because we have that horizontal asymptote, that there is no x-intercept on the parent functions. It's going to be smooth and continuous curve, and it's going to pass through those points there. Talks about the horizontal asymptote, and we know that if x changes signs, then it's a reflection about the y-axis, and we know that from back in 1.5 when we talked about the transformations of functions, which leads us to this next slide here. And so in here it talks about the different types of shifts. Now they use different letters than what I used in class the other day, but it's the same thing as when we did 1.5. And we looked at all the different functions and we said like y equals a times bx minus h and then plus k. It's the same exact thing, but now it's going to be y equals a times your base raised to your bx minus h and then plus your k. Everything's going to do exactly the same. A is still your vertical stretch or compression by whatever a is. B is still your horizontal stretch or compression by 1 over b by its reciprocal. Remember, anything that's with x is going to do the opposite. So that b and h are going to do the opposite of what you think it should. The h is your horizontal shift left and right, and then k is not up there with the x, so it is your vertical shift, and it's going to go up or down. And so you can go back to your 1.5 notes and look at what we talked about then. We wrote down a whole bunch of stuff about it, or you can just read through this slide here. All right, so to sketch a graph of y equals 3 to the negative x plus 2, let's find the domain, the range, and the horizontal asymptote of f. So I can see that 3 to the x is my parent function, and so I'm just going to remember what my table was. We created it earlier. We said our x's for from negative 2 to positive 2, and we can just plug those in. So I got 1/9, so 1/3, 1, 3, and 9. All right, so for this one, oh yeah, and don't forget you had that horizontal asymptote at y equals 0. So now this one here has a couple things happening. First thing that I notice is that 3 to the, I'm going to rewrite it down here. So we have y equals 3 to the negative x plus 2. That negative x, remember, it's going to be a reflection across the y-axis. And the 2 is going to be your vertical shift up 2. So when we go to do our table, what's going to affect our x's? Well, we have that negative x, so really that means we divide by -1 or multiply by its reciprocal. And so let's do that. So 2, 1, 0, -1, and -2. And then my y's, we're going to add 2. So I'm going to take all of my y's here and I'm going to add 2 to them. Now, also remember you have the horizontal asymptote. Well, it was also a y equals, and so whatever you do to your y values, you're going to do to this. It was y equals 0, but we said we're going to add 2, so now it's going to be up at 2. All right, so let's graph this. I'm going to draw in my axes. I'm going to graph my asymptote. Make sure you don't cross that horizontal asymptote. And put arrows on both ends.